In this video, we're going to learn to use symmetry and the empirical rule. A standardized test is approximately normally distributed, so the scores are approximately normally distributed, with a mean score of 72 and a standard deviation of 8, as shown in the graph below. So we're given a sketch of the normal curve, and it's labeled with a mean of 72 and a standard deviation of 8 for us. Now we are asked to use the symmetry of the normal curve and apply the empirical rule to answer the questions. So notice that, or recall that, the normal curve is symmetric with respect to the mean. And that means if we look at this line, the left-hand side is the mirror image of the right-hand side. So this is our line of symmetry. Okay. So let's read the first question. What percent of students scored greater than 72? So that would be above the mean, which is 72. Well, let's think about this. We know that underneath the curve, okay, is 100% of the data. Okay, so that's the total amount of data that lie under the curve. Remember, this is getting closer to the horizontal axis, but it never really touches because higher scores are possible, just improbable. And they are so close they look like they're touching, but they're not. Okay, so now if this splits the graph down the middle, that means that these two sides have equal area. So that would be 50% lie to the left of 72 and 50% lie to the right of 72. And notice that also matches the idea. We said that if we have a symmetric distribution, that the three measures of center are equal. So the mean is also equal to the median. It's also equal to the mode. And by definition, the median is the point where 50% of the data lie above and below. Okay, so the percent of students who scored greater than 72, well, that's half, or as a percentage, 50%. What percent of students scored less than 72? Well, that's the other half, 50%, giving us a total of 100%. So these two groups include all of the students, so they should sum to 100. Let's look at the next one. What percent of students scored between 64 and 72? So let's just highlight this area. So between 64 and 72. Okay. So notice we don't have an exact value from the empirical rule for this. The empirical rule tells us, I'll pick another color, that these two areas together within one standard deviation in either direction of the mean, that's 68%. Okay. But notice that since these are mirror images, this green area is equal to this pink area. So that means if we know that 68% are these two combined and each of these areas are equal, we can divide by 2. And this area right here equals 34%. Okay. And let's notice if this area is 34%, then this area right here is also 34%. Okay, so I just took the 68%, divided it into two pieces, and we know each of these areas. And that's actually what the next question asks. What percent of students scored between 72 and 80? Well, that's between, let's just highlight it again, between 72 and 80 is this area right here. And since we found the previous area of 34%, this one is 34% as well. Let's look at the next questions. In Part E, we're asked what percent of students scored between 56 and 72. So let's highlight this area. It's always good to make a little sketch so you know what you're looking for. Okay. So notice this is to the left of the mean, two standard deviations up to the mean. Okay. So we're going to use the same idea on the last problem. We know that if we went 2 standard deviations in both directions, okay, I'm not going to shade this. Well, I'll shade it a little bit. All of this area equals 95% by the empirical rule. So this is 95%. Okay, but we just wanted the area between 56, let me get a highlighter, 56 and 72. Okay, so this piece right here is half of the 95%. Okay, so we have 1/2 of 95%, and you can find this by hand or on your calculator. Divide 95 by 2, equal pieces, is 47.5%. Okay, so now we know that half of this 95% area, if we just go to the mean and 2 standard deviations in either direction, either 56 to 72 or 72 to 88, the area is 47.5%, or the percentage of students. Let's look at the next one. What percent of students scored between 72 and 96? So we're given the mean again as one of the boundary values, and now we're going up to 96. And 96 is 3 standard deviations above the mean. Okay. So like we did in the last problems, okay, we know 99.7% is within 3 standard deviations in either direction, and the boundary values we were given would be half of that. So we have 1/2 of 99.7%. So we could take 99.7 and divide by 2. And that area is 49.85%. Let's look at the next one. What percent of students scored less than 80? Okay, so here's 80. So we want every score to the left of 80. Okay, so we're going to use 2 ideas of symmetry here. Okay, so it's tempting to use the 1 standard deviation because we have this whole piece, which is 68%. Okay, but let's include, I'm going to draw a green line right here, the fact that we know 50% is below the median, which is also the mean. So here we have 50%. And then remember from the previous problem, within 1 standard deviation of the mean, so these 2 together is 68, but just each piece is 34. So this piece right here is included in the 50%, and this piece here is 34%. So if we add these 2 together, we have 50% plus 34% gives us a total of 84%. Are less than 80, excuse me. So notice if you're given a question where it says are less than, it's only 1 boundary value, or greater than, okay, you're likely going to use either 50% or 100% in your computation, and then some part of the empirical rule. One last question. What percent of students scored greater than 96? So here's 96, and it's this little piece of area that's so small we can't even see it. So we know that's going to be small. Okay, so what can we do here? So notice it says greater than, so we're going to need to use 100% minus something, or 50% minus something in this case. Okay, so why don't we use, I'm going to go with the 50% one. We could actually use part of a last answer, but then we'll compare it later. It'll be more fun. Okay, so we know 50% of the data is greater than 72. Okay, now we know that between 72 and 96 is half of the 99.7. So 1/2 of 99.7% is within 3 standard deviations on this side. Do this in blue. Okay, so this is half of 99.7, I believe, oh, we already found that, which is 49.85. Okay. Well, if we know everything to the right of 72 is 50%, since the mean equals the median, then this little piece must be the difference between those two values. So 50% minus 49.85% equals, it's good to do this on your calculator because these could be tricky, but it's 0.15%. And notice this is already a percent. You don't need to multiply this by 100, but let's just do 50 minus 49.85 to double check, and it is a percent already.